Okay, circle theorem. This is going to be the first worksheet, which is going to be the basic. Just learn all of the theorems. Okay, so first of all, let's start with the first one, the easy one. I'm just going to draw it here. So if you have a circle, and that is the center of the circle, and that would be the diameter of a circle, and within the diameter must be a diameter. Remember, if you draw a triangle, okay, this angle is 90 degree. Okay, so basically, if you have a semicircle, or let's call it an angle in semicircle, equals 90 degrees. Is that okay? So that is what, this is your theorem number 1. Okay, this is what you write. Okay, because remember, these questions are going to be 3-4 mark question. They're going to say give reasons, and this would be the first reason. Okay, let's do some questions on this. Okay, so if you look at this one, say this is a, first make sure it's a diameter, right? It is a diameter, so this angle is 90, and x will be what, 180 minus 65 minus 90. X will give you what, 25. Okay, next one, same thing. X is 180, this is a 90 degree anyways, minus 34 minus 90, and x will give you 56 degrees. Okay, same thing again. This is angle in a semicircle is 90. X is equals to 180. 180 minus 50 minus 90, which is a 40 anyways. Okay, you don't need any calculation, just do it in your head. Okay, now here this is a what triangle? An isosceles triangle, but it is also an angle in a semicircle. So that is 90. So what do you do? 180 minus 90. But then remember, these are base angle in an isosceles triangle. This one and this ones are the same. So that's x, that's x. So 180 minus 90 divided by 2, which is x is what number? 45. So there will be two reasons you write. One is base angle in an isosceles triangles are equal, and the second one is angle in a semicircle is 90. All right, just a couple more questions. Here, this one is not an angle in a semicircle. I just thought I would put it. What is this? This is base angle in an isosceles triangle, because this is your radius, that's your radius, so these are the same. So that's the same as that. So both of them are x technically. So it's just 180 minus 98 divided by 2. That will give you, what's that, 82 divided by 2 is 41 degrees, because the reason for this is you just write base angles in triangle are equal. Okay, so this is nothing to do with that one, but okay. Right, here just a couple more questions and we will be done and out. If you look at this one, what is x and what is y? So remember, this is radius, that's radius, these are isosceles triangle. So technically this angle is same thing as that angle, so that basically means z is what number? 22. And remember, because can you see this full triangle? Sorry, can you see this full triangle? This is inside the diameter, isn't it? The angle in a semicircle, so this angle over here. Then angle in a semicircle add up to, angle in a semicircle is 90. So what is x is then? Just 90, take away that this 22 here, isn't it? Which makes 68. Okay. Then if you look at it, so I know what x is. That is 68. And this is a radius, that's a radius. So these are isosceles. So that's the same thing as that. So that's 68, that is also 68. So then what is y is? Y is basically 180 minus 68 minus 68. Y will give you, that will give you 136, which is what? 44. Okay, y is. Okay, this one is also angle in a semicircle add up to 90. So that means this is 90. So this is right angle triangle. And you just do Pythagoras on it. X is shorter side, remember, square root of 10 squared minus 8 squared. That should give you 6. This one, angle in a semicircle is 90, so that means this is 90. So you just do Pythagoras to work out the x. X is a longer side, so you add it. 12 squared at 5 squared. What's that? 13. Okay. Just use the fact the angle in a semicircle is 90, and then everything is fine. Okay. So the second one in here, okay, which is, sorry, the second rule. Now we will call it, okay, we done the first one, which angle in a semicircle is 90. The second rule is, if you have a triangle circle, okay, you have to go from the center and it will look more or less like this, and this angle and this angle, if this angle is x, this angle is 2x, okay, it needs to look similar to this, okay. So what is this called is, angle at center is double the angle at circumference. Okay, so that basically means angle at the center, this angle is double the angle at circumference. Okay, simple. That's the rule, and that is your second circle theorem. That is the reason you write. Let's start. So angle at the center is double that. So x is what double of that is. Why is it doing that? Okay, right. Okay, no problem. Just answer. No, x is what? Okay, I will just write the answer here, which is the answer. Okay, don't worry about it. X is double that, 51 is 102. This x is half of this 122, isn't it? Because it's half of that, which is 61. X is half of that, 70. This is x is double that, which is 76. This x is half of 165, which is 82.5. Okay, yeah, there's nothing wrong. This is angle at the center, anyways. Angle at the center is double the angle at circumference, so I need to half of this, which is 97. This one, okay. This angle, what is this angle will be? This angle is double the angle at the circumference. The angle at the center double the angle at circumference. So this will give you 110 double it is 220, but x is not 220. X is around a center point, around a point, what the total angle is? 360. So 360 take away that 220, which will give you 140. Okay, right. And if you look at this one, this is your angle. If you look at this, is a straight line anyway. So 180 minus 142, which will give you what? 38. And then angle at the center is double the angle. Double 38 is 76. X is 76. Okay, angle at the center is double the angle at circumference. This angle is half of it now. 136 divided by 2. What is that going to give you? 70. So that's 68. And this is the straight line. So total in a straight line 180. So 180 minus that 68. 112. Next one. If this is 266, so what is this angle? Because around a point, total angle is 360. So 360 take away that 266. Which will give you what? 94. So that is 94. Angle at the center is double the angle at circumference. So I want half on that one to do this guy here. So half of 94 is 47. Then this is a straight line. Can you see? So 180 minus 47. Which is 133 axis. Good. Then how to work out A is easy. Angle at the center is double the angle at circumference, which is half of this now is 56. If this is 112, what is this angle is? 360 minus 112. Can't do that. 510, 8, 4, 2. So that's 248. Then if you switch it and if you look at it the other way around, this is the angle at the center, this is the angle at the circumference. So that should be double that. So B is half of that, 124. Okay, so you should be able to look at the other way around as well. Okay, that's a nice question to do. All right, this one. Isosceles triangle, because this is your radius, that's the radius. Base angle at the isosceles triangle are the same. So that's 22, that's 22. This will be what then? 180 minus 22 minus 22, which will give you 44, 136. Okay, and then this is 136. Angle at the center is double the angle at circumference. X is just half of that, which is what? 68. Good. Okay. So you go to so because they could give you any way around it. It's very easy. Just remember the rules and then you should be fine. Right. That's rule number 2 is done for the circle theorem. Third one, you would get, there you go, 1. I will do that. I will do that. If this angle is x, this is also x. If this angle is y, this is also y. Because the reason is, it's called angle in the same segment are equal. Okay, that's why x is, that's these two are x's and these two are y's. And remember, I don't know, remember if you look at this, this is technically the same thing as this because vertically opposite angles, isn't it? These two are, okay? That might come later. So angle in the same segments are equal, so x is what? 50, x is 24. It's all of them are the same angles in the same segment. 37 for B, A is 37 as well, 81, 97. Okay, this one looks very similar to what number? 52, so that's x is 52, yeah, angle in the same segment. And then they want, what is this? Okay, 91. If they, okay, why bother saying 91? No point. Okay, that's fine, not a problem. This one, z angles. Look at this, because the parallel lines, alternate angles. If I do that, that's 40. Why? These are alternate angles are equal. If this is 40, x is also 40 because angle in the same segments are equal. That is because these are parallel lines. Okay, if you're parallel line, just think about alternate angle, corresponding angles, co-interior angles. This one is an alternate. Okay, this one, if this is 84, this is also 84. Vertically opposite angles are equal. And what about these angles? So so 360, take away that 84, take away 84, and then divide by 2 because you got the same thing. 84 is 168. If we take it away, 168 is 192 over 2, I think. That will give you what's that? 96. So that is 96. That is also 96. If that's 96, what is this angle? 180 minus 96 minus 25. What's that? 180 minus 96 is 84. 84 take away 25. 74, 64, 59. I think that's 59. If that's 59, this is also 59 because angle in the same segments are equal. Okay. Next one. The easiest one. Okay, this is like the easiest one to do always. But if you want to find in a question, you have to always look properly, okay? Because they can play tricks on it. So this is called a cyclic quadrilateral. Sorry. Okay. The key point is, if it's a cyclic quadrilateral, make sure all the corners of that quadrilateral, like the four-sided shape, is exactly on the circumference of the circle. Okay. So if they said this is x, this is y, you just remember x plus y equals 180 because opposite angle in a cyclic quadrilateral add up to 180. If this is 70, for example, this is also opposite here. This must be 110, basically. Okay, because the reason is opposite angle in a cyclic quadrilateral adds to 180. Okay, but remember that is not a cyclic quadrilateral because this one is on the circumference, that is on the circumference. This corner is not on the circumference, it's somewhere inside a circle. So this is not a cyclic quadrilateral. That is. Okay, all the corners must be on the circumference, otherwise it's not acceptable. Okay. Right, x is opposite of that guy. What's that? 180 minus 97. I don't know what to do with the guy. Okay. Right, this is 180 minus 97, which is 83 on this guy. And the other one is 180 minus 76 is 104. Y is 104. Opposite, that's 130. 180 minus 85, which is 95. Okay, that's 180 minus 140 is, there you go, take it away, 109 is it? Okay, they might play some tricks because there's parallel lines, remember? Okay, these two angles are what, co-interior, remember these two angles are because of C, co-interior angle, so 180 minus 101, which will give you 79, that's 79. These are opposite angle in a cyclic quadrilateral add up to 180, which makes it 180 minus that, 79 also. Opposite angle in cyclic quadrilateral add up to 180, so 180 minus 79 is 101. Co-interior angles here. How about C, isn't it? C, letter C means co-interior, letter F means corresponding, letter Z means alternate angles, because these are parallel lines. 60, you know what I will do? Actually, I'll work out the Y. 180 minus 60 is 120, that's 120. Opposite angle in a cyclic order add up to 180, so that's 60. Okay, if that is 85, opposite angle in a cyclic quadrilateral add up to 180, so that makes it 95. This is a straight line, can you see? So 180 minus 95, which will give you 85. Okay, so this is 140, and this is opposite angle in a quadrilateral, so cyclic quadrilateral 40 add up to 180. There you go. Then x is what then? 180, because can you see the triangle here? There, that triangle here. 180 minus 40 minus 72, because you know total angle in a triangle is 180 anyways, which is 68. Opposite angle in a cyclic quadrilateral add up to 180, so that's 180 minus 46, 134. And then x is just because it's a triangle, can you see the triangle? There you go. 180 minus 23 minus 134. 23. Yeah. So that basically is a isosceles triangle then, 23, 23. Yeah, nice. Okay. First, x is what? Angle at the center is double the angle at circumference. You remember the last ones, the one before last one, I think. So as x is 72, you double it. You double the 36, 72. Y is opposite angle in a cyclic quadrilateral add up to 180. Right, so 36, so 180 minus 36 is 144. Okay, simple. Right, next one. So if you have a tangent, how do you know it's a tangent? You must start from a center and you go to the circumference, and what they tend to do, that's 90, that's 90. Because just say tangent equals 90 degrees. Okay, just as long as it's a tangent, it's 90 degrees. So this is a tangent here, that's a 90 degrees. So x is what? 180 minus 90 minus 27, which is 63. This one is a tangent, so that's a 90 degree. So 180 minus 90 minus 68, which would give you 22. Okay, if you look at it, this is 90 degree. If that's 154, this one is a, of course, can you see a straight line? 180 take away 154 is 26. If that is 26 and that's 90, what's that? It's a 180 minus 26 minus 90, because total angle triangle, isn't it? 64. That's a straight line. 180 minus 64, 116. That's 90. 90 plus how many x? 3x should give you a total of 180. 3x is take it away. 90. X is 30. Okay, this is what most likely to come up in the exams. Okay, remember that these two are 90 degrees because these are tangents. So remember, so the trick to do this, but you write the reason, be like, oh, tangent is 90, just say that. But you know for a fact this is a quadrilateral, okay, not a cyclic quadrilateral, just normal quadrilateral. This is 90 and 90 goes, so 360, 90, 90 take away is 180. So these two technically add up to 180 always. Okay, because this question always pops up. So 180 minus 158, okay, which is 22, and then 180, because you know that these two are tangent, 90. 180 minus 15, that gives you 165. Okay, right, so we are done on that. Last one. Okay, it doesn't have to go through the center or anything, just a triangle inside that circle exactly. And then if this angle is x, this angle is also x. This is y, this is y. This is called angle in alternate segment are equal. That's the reason you write. Okay, angle in alternate segments are equal. So if you look at it, this one is 70, so that's x is 70. So that's 55, so alternate segment, this is 55, 60, that's 60. Okay, what's that? That's 63, 65. Can you see? You could do the triangle here, or you could do the straight line here. It's up to you which one. So just 180 minus that 63 minus 65, 52. Okay, that's 64, that's 67. Okay, same thing applies. If this is 81, this is 81, because angle in the alternate segments are equal. This is an isosceles triangle, so these two angles are the same, so that and that is the same, so that's 81. If that's 81, that's also 81. You can do the straight line on the triangle, so 180 minus 81 minus 81, which is what's that, 162, 18 degrees. This one. If this is 80, what is this? Angle in the alternate segments are the same, 80. If this is 80, what is this? This angle. Because the angle at the center is double the angle at circumference, so y is 160. And it is a radius and a radius, so it's a isosceles triangle. So the bottom angles are the same, that's that. 180 minus 160 divided by 2, which is 10 degrees. Okay, so these are the basic ones that you need to know. Okay, just make sure you learn this, the whole thing. There's nothing after that. Okay, make sure you learn it, and then go make sure, remember, where is it? This one. Angle in the semicircle equals 90 degree. Simple. Next one, angle is the second one. Angle at the center is double the angle at circumference. Okay, circumference. Third one, angle in the same segment are equal. Sorry, angle in the same segments are equal. Fourth one, opposite angle in a cyclic quadrilateral add up to 180. Fifth one, that's easy. Tangent. Tangent at a circle. Tangent at a circle. To be honest, if it's at a circle, it wouldn't hurt. Is equal to 90, whatever. 5, 6. Sixth one, angle in the alternate segments are equal. Okay, all 6, and then you should be able to do it. Okay, make sure you practice it. The next sheet I will put through is